It's the first day with the new laptop, so my deepest apologies to everyone. To let you know a little bit about who I am, my name is Alison Cossette. I am here with Neo4j representing our workshop today. So let me see. Here we go. Here we go. All right. So hopefully everybody can see everything now. I am here with Neo4j, and I am going to be walking you through how we get structured data and unstructured data into a GraphRAG system so that you can run your agents. So what I have available for everyone, the good news is, and what's pretty exciting about Graph Academy is at Neo4j that we have a ton of free courses that are available and free workshops. This workshop that I'm walking you through today is usually 2 hours, so I'm going to give you the compressed version, but the good news is that this workshop will be available to you at any time. So if you want to go to the URL and run this yourself, it's going to be graphacademy.neo4j.com/courses. And the name of the course is Workshop-Gen AI. Can everybody see my screen okay? Raja, hopefully you can. And what we're going to be doing,
Alison.
Excellent. All right. So again, so all of this is available and it's free to you. We're kind of giving you a little bit of the compressed version today, but what I'm going to do is I'm going to walk you through all of these pieces. So to tell you a little bit about what we're talking about, many people have, and I'm actually just going to, you certainly don't need me to go over the basics of what is Gen AI. Obviously, everybody here is perfectly familiar with that. But what I do want to talk through is I want to talk through a little bit around the model. So we clearly know that when we're working on RAG applications and we're working on agent applications, we're really trying to, in our case, use how we can use data to improve what's coming out of the language model. The way that we do this in our instances, what I'm introducing you to today is a knowledge graph. So the knowledge graph is actually built based on nodes and relationships. So when we think of how RAG works and what we're grounding in, what we're going to be grounding in today is not just, everybody's pretty used to a vector database. What we're going to do is we're going to expand that concept of the unstructured and vector database and expand it to include your structured data. So some of the basics about graph are we have nodes and relationships. So you can think of it like if you've got a table of people and a table of company. In our case, we're working with SEC data today. So we have a table of asset managers and we have a table of companies, right? So these asset managers own shares in these companies. In a traditional relational database, you would have probably a lookup table that would have the name of the asset manager, the name of the company, and then some parameters. So they own a certain amount of stock at a certain point in time. And so in general, the way that you can think of the relationship, not to use a relationship, but the connection between relational and graph is if you've got a lookup table in your ERD, in a graph, that would roughly be what we call a relationship. So those elements that are on that table would then be properties on the relationship, which is what we have here. So just to give you a little bit about that, I know everybody's looking forward to learning another language, but the language that we use to query the database in Graph is called Cypher. The good news is we have a very clear, consistent format around that language. Much of it is very similar to what you'll see in SQL, right? So you have a return statement, select from where, but rather than that, what we have is we have match and return. So what we're looking for is we're looking for patterns in the relationship. So if historically in SQL, you would say, from asset manager, join lookup table, join company, and you would have this very complex piece. In our case, we're saying, just match me the asset manager who owns companies. In this case, we're saying the asset manager is Andre, the asset manager that owns the company, and then return whatever those properties are. So just a little bit of a heads up that we're going to be using Cypher. When we do retrieval augmented generation, in our case, what we're looking at is using the knowledge graph as that external grounding piece, which is what we're looking at here. So how do we actually go about building the graph? So there's a number of different ways that we go through it. And we will walk you through a little bit of it here, and then I'm going to show you some things in the notebook itself. So obviously we know the challenge with traditional RAG is that when we're using a vector store, we're really returning based just on similarity, but not necessarily on understanding or business logic. I always like to use the analogy of a vector database is kind of as if you took, let's just say I'm onboarding a new employee and I have an employee manual. If I took that manual and chunked it up and tore it into little pieces and put them on index cards, each of those little pieces has information. But if I say, show me the index cards that are similar to, I don't know, a time off policy, maybe there's an additional piece of metadata that's connected to it that it may not be. But what we really need to be able to do is we need to be able to take the information but connect it to other things, which is what we're really doing in this particular instance, right? And so that's what we're going to be working on today is how can we expand that vector database to add in additional structured data to that unstructured data. So in our example that we use in this workshop is we have PDF documents, and these are about companies and finances and different risks associated in that unstructured data. And what we're going to be doing is we're going to be using AI to extract those entities and relationships, ultimately setting up for how we put it into an agentic solution. Now, the idea is, and at the end, we're going to show you just a simple agent. But what we really want to focus on today, and I want everybody to get out of this, is you've got lots and lots of conversations in this yesterday and today around how we're building agents. And what I want you to have from this is how do we put together the optimal data to get the best possible output from our agents, which is mostly what we're going to be focusing on today. So in this case, what we're looking to do is we're looking to connect our unstructured and our structured data. So for example, we're familiar with this process here on the left. We have the document and we create a chunk from it. This is your traditional vector moment. But what we also want to do is we want to be able to have access to the structured data. In our case, we have some structured data around which company is connected with that document. And the first thing that we're going to do is everything you see in red is going to be structure that's extracted from the unstructured data. So within these SEC filings, they talk about products, they talk about stock types or transactions or risk factors. This light blue element you see is actually coming from, in our case, it's a workshop, it's a toy example, a CSV that outlines which asset managers own these individual companies. And so what you have in the end is what we build out is we built out this combination of your unstructured data in this vector moment. We have structure extracted from the unstructured, and we have whatever your traditional data would be as far as that structure is concerned. So this is what we're working up to today. What is the data that we're going to be working with and what's used here? What we have is we're using Edgar SEC filings. As we can see here, the original challenge might be, how do we extract this structured insight from thousands of pages of text? In our case, we're talking about these quarterly filings that get filed with the SEC, and that's what we're going to be working with. And what we do is we take those documents and they're chunked and the vectors are created. So just as we can see here, what we're going to do is we're going to match the document. In this system, when you run this in Graph Academy, this data is already loaded for you so that you can play with it. And clearly what we're seeing here is we've got this particular PDF was chunked into 99 chunks, 72 chunks. Everybody knows there's an art to the chunk, but really what we want to show you is right now, when we looked at that diagram of the document and the chunk, what we're looking at is give me back this path. So show me the document where those chunks are coming from. What that looks like is I can actually, let's say match, I'm going to de-document. I'm going to create this. I'm going to look at the, again, this new laptop. I'm going to look at the from document, right? And then I'm going to connect that document to a chunk, okay? All right, and then what I'm going to do is I'm going to return, let's just return star, and we're going to limit to, let's say 10, just so we can get a look at what this looks like. And the reason I'm running it this way is what I want you to see is I want you to see the actual graph. So in this case, we've got this one particular document. We see that this document, these chunks, this particular chunk is from this document. And the other thing that we see is we see next chunk. So again, this is another way that we can, maybe you're building an agent where you want to bring back that vector chunk, but you want some context. So you want maybe the chunk before and after. In these cases, by having them set this way, it allows you to bring in that immediate bit, but also see how everything is set up within the graph itself. What we've done, and I'll show you the, I'll walk you through what's in the code as far as how we're extracting this in just a minute. But what we've done is we've then done the schema-driven extraction. So what we've done is in the GraphRAG notebook, we've said, okay, I want to look at the companies. I want to extract entities such as executive, product, financial metric, like we had seen on that earlier layout. Then I want to also create these metrics here. And what this ends up looking like, we've got our code spaces up here. When we are in the document, you're going to see the our financial documents. What you'll see is the PDF build. So in the PDF build, this is actually going to show you, this is actually the notebook that walks you through how we actually did that. So clearly we set up your .env file. One thing to note when you're using Graph Academy in this particular workshop, one of the things that you're going to see, hold on one second. Close this. When you go to set up your, oh, why is this not working? What is my retriever? Uh-oh. What is happening? Uh-oh. Why is this not? Uh-oh. All right. Well, I'm not sure exactly why this isn't loading for me right now. Hopefully you guys can still, Raja, can you still see what we're showing right now? Hopefully. All right, I'm not really hearing anything, so I'm assuming that everything is okay. As I mentioned, one of the challenges that we're having right now, I don't know why this is not running to my next piece. All right, we've got our vectors. What is a retriever? Set up your development environment. All right, well, it looks like now this is actually running, which is good. In this particular course, when you go to setting up your development environment, one of the things that you're going to see is you can open in GitHub code spaces. So all of the documents associated with this will load. But the other thing that you'll see is you'll see the connection information. So you will have to bring your own open API key to run this, but what we see clearly is that we've got the information. So this database, this instance is going to get set up for you right away, and then it will be connected. It'll be connected separately. So let me move this out of the way. All righty. All right, hopefully we can still see everything. So just to understand what's happening inside the instance itself. So how we actually did this PDF loader is we went through and we want you're going to set up your .env. This information here is coming directly from Graph Academy. We're going to give this to you here. You can drop those in. You can also set it up with a .env file as you see fit. And what we've done is we've gone through, and the first thing we did is we created these documents in chunks, right? We create these documents in chunks, and how do we actually do that, which is what we're looking at here. In my case, as we know, when we're trying to set up data that's helpful to our application, we always want to be mindful of the messiness of the data. I come from a long time data science background. I think I spent the first 5 to 7 years of my data science career mostly cleaning up data. And that's one of the interesting things to know about the new AI engineer moment is you really are, you're not just an SWE anymore, you're not just an engineer anymore. You really do have those data science and those data management skills. So what you'll see in this particular instance is we actually provide some additional information about how we want the names of the companies to be extracted. So the first thing that we do is we initialize the LLM. This is still set up with GPT 4.0 rather than 5. You can certainly adjust it to the model of your choice. But what we've asked it to do is we've asked it to go into the unstructured data and say, find that we have the company that's associated with that document and go in and extract all of these different elements. Now, I'm showing you one very particular structured way to go about it. We do have MCP servers available to help you do this. There's lots of ways to approach this, but in this case, what we're showing is we're showing you a very structured format. The reason I like the structured format is when we are in a non-deterministic space, any opportunity we have to get really clear and to bring some structure, I'm always going to opt for that. So one of the things that we set up, the way we set it up is we set up this Python dictionary where we say, okay, I'm looking for the label, the node label, that's the type of the node I'm looking for, which is an executive or a product or a financial metric. In this case, when I'm looking at the actual properties, I'm just looking at, I'm just looking at the name and inputting that as a string. You can, if you're looking for dates, you can set those in to return as date times. This is where you really want to get very clear about what is it in this unstructured data that's going to be useful to me, and how do I want that information to be put into Neo4j so I can access it. The next thing that we see is we see the relationship. So in this case, we're saying, I want to look at the relationships, has metric, faces risk, etc. And this is what we have here, say risk factor company, the relationship between them is called faces risk. As I mentioned, I put in an additional prompt template because I wanted to be very clear that I need the company names that are extracted to match what's in my structured data. And this is something where you always want to be thinking when you're looking to take that unstructured data and make it available in a GraphRAG application. You always want to be thinking of what do I have in my structured data stores that can be found in this unstructured data, and how do I make sure that that jump match is going to tie? In Neo4j, we have plenty of algorithms around entity resolution and different pieces like that. But in this case, I just wanted to show you a way that we bring in this prompt to run that. So the next thing that we do, and this is really the key here that I want to really highlight, is we're using the Neo4j GraphRAG package, and we're using something called Simple KG Pipeline. And in this instance, what we've done is we take the driver, which is connecting to our instance. We have the LLM that we set. As always, you want to make sure that what your embedding model is how is going to tie to how you're querying. But what we see here is then we're passing those dictionaries of the entities and the relationships. I also passed in the prompt template. And then there's something called enforce schema equals strict. And that means if you don't sort of rein in the LLM, it's going to find all different kinds of entities, all different kinds of relationships. And in this case, you want to really tie in and get really clear and clean on what that is. So when you run this, we ran this over the data set. And what we do is we run this pipeline, we ran it on all these PDFs. And then at the end, we create this vector index. And where you see this is you see this, as I mentioned, in our building of the graph. Let me take you back to here. This is everything that was done in this element, and this is what got us to this moment here. This is what got us to the ability to say we have all of these chunks. So what we then want to do is we want to say, okay, well, you ran all of this data here. When you've extracted these elements, how can I take a look at those? So here's one way that we can look at it. So once we ran this, we came out with 820 risk factors, 470 financial metrics, and this is showing us all of those entities that were extracted. A little piece about how we dropped in our structured data. So in addition, what you'll see in our second notebook, and I can share this with you one moment. In the second notebook, nope, the second notebook here, the loading the structured data, we show you a visual. There isn't actually any code in this particular notebook. It's really just the walkthrough of when you have your own data and you want to load it in, how could you go about that? So it encourages you to go to console.neo4j.io. One thing to know about Neo4j is we do have a free tier instance. We also have a community edition where if you want to download something locally, we have a strong open source soul at Neo4j in our origins. So we really want to make it accessible to you. So when you go to console, the Neo4j Aura console, which is our instances, we have a really clear walkthrough of how you actually will load in that data. One of the things to note is we've got these different asset managers in the companies, and we show you how to actually map out, and it's very, very detailed in case you want to see what these look like. We have all the walkthroughs of how do you add in a node, how do you add in a label. We do have a lot of, we do have many connectors. As you see here, we've got lots of ways that you can connect to your data. And the key is you ultimately want to be able to tie your unstructured and your structured data together. So there is a walkthrough in here in the financial documents PDF build about how you actually get to that moment. So the data that's in there and what we walk through in that notebook is what we see here. We have the name of the manager, the company name, the ticker of what they own, and what those values and those shares are. So as we mentioned, we've got this walkthrough of how you can do, say, a GUI load. We have many other ways that you can do it as well, and we talk you through that there. The interesting thing for me is once we actually get all of that loaded in, we now see that we've got what was extracted from the unstructured data, right? Those risk factors, financial metrics. We have the chunks where those PDFs were added in. And then the other thing now is we've got this asset manager. Now, in our case, we only have 15 asset managers. We only have a handful of companies. I think we have 8 or 10 companies range of documents. But one of the things that we note is that now you can actually take a look at a whole company. So what does that look like? So to dive in a little bit to the Cypher query. So here we're saying we've loaded these documents from Apple. And what we want to say is we want to show we add what we call optional match. An optional match just means if it's there, show it to me. But if it's not there, don't break the query. So bring me back Apple. Show me if there are asset managers that own them. Show me if there are chunks. And then here, what we're doing is we're just doing the aggregation, right? So give me the counts on these. And what we see is for Apple, we have 175 extracted entities. So those are the products, executives, risk factors that we had discussed. We see that of our asset managers, 15 different asset managers own a portion of Apple. And we have approximately 44 text chunks that are associated with Apple as well. And you may be saying, how might this be of interest to me? And what I can show you is let's actually also look at, let's just do, instead of doing this, I'm actually just going to do a return star. I'm going to limit it to 25. And I want to show you a little bit about what this ends up looking like in the graph. So in this graph, what we're seeing here is we've got Apple. We've got all of these different entities that were extracted or a risk factor. So in this case, it faces a risk of, this is probably adverse macroeconomic conditions. We can see that it faces a risk of political uncertainty. So we have all these different types of risk that it might be facing. The other thing is we're also seeing an example of an asset manager that owns Apple, right? And then this, we're seeing like an example of one particular chunk. And we also note that this particular risk that it's faced, which is geographic some piece, was found in that chunk. So under the hood, each of these entities that we've extracted is tied to that chunk. That chunk is tied to the company. The company is tied to the asset manager. And you may be asking yourself, why do we need all of these connections? How does this actually help my agent? It's going to help your agent in a variety of ways. One of the things I'll talk you through is, let's actually go to the retrievers. So when we talk about retrievers, we're talking about the ways that we can query the database and use that information as context. So whether you're using it as context for your agent for a memory moment, whether you're using it as context for like an actual, NLP verbal response or written return. There's lots of different ways that you're going to be using this data in your agents. But what I'm going to walk you through is I'm going to walk you through a couple of ways that we do this. So everybody's familiar, I imagine, with your vector retrievers and your vector search. In Neo4j, the way that this is stored is in the, so let me actually do this. I'm going to show you the chunk. We're going to match the chunk, and we are going to return C limit 1, because I want to show you what it actually looks like in the, here we go. So we have a node here that's the chunk, but what's actually in that element? So one of the things we see is we've got this chunk, the chunk has an ID, we've got our embedding, which we're used to, that vector. We have the text associated with it. And these are the important pieces. So when we think about doing a vector search, what we're doing here is you still have that vector search and vector index like you do in a vector DB, but now it's a part of the actual node. And this element that we saw before, where we have this chunk, now we can say from this particular chunk, let's say I do a search on, and I do some sort of a vector search on a query. Now what I'm able to do is I'm able to, from that particular chunk, go to the company, or go to the asset manager that owns the company, or go to an extraction. So when we do this initial vector retriever, all that we're doing is a basic vector search. So if I say, what are the risks that Apple faces? I create this vector retriever. Here, what I'm doing is I'm passing it the driver. So clearly we want to connect to the database. The vector index that we created was called chunk embeddings, using the same embedder that we use to embed within the model. And I want to actually return just the text from that. So this is what that retriever is built to bring back. So then when you run this, I don't have them run here, but you'll be able to run these directly yourselves because everything's loaded in already. What you're going to get is you're going to get those results. And in that case, you're going to have like a very clear table of what's returned. Within the GraphRAG package, you can actually turn it back into natural language. And we can do that by doing GraphRAG, which says, okay, give me the LLM, run those vector retrievers, and then give me those answers, right? Where things get more interesting is when we're talking about the contextual cipher retriever. And this is where GraphRAG is really going to sing, because what we want to be able to do is we want to be able to go and traverse the graph itself. So what does that actually end up looking like? So we can take you to our retrievers. Let's go to working with retrievers. And this is where you can actually run the retrievers yourself, and you can run them in here. So for example, I'm creating a vector retriever. I am going to embed that, and then I want to get a response back. the interesting thing, like I said, about the GraphRAG is that you're not just looking at the vector. You're looking at the vector as it ties to the other elements of the graph itself, right? So if we look at how we actually built the graph, let's just say I want to, so let me do it this way. So let's just say in our case, we are looking at this contextual piece, right? So I want to, sorry, go to our advanced drag. I want to be able to traverse the graph. So let's just say I know that my agent is often going to be used to, it has a tool, and I want that tool to be able to give me back risk factors for a particular company. There are a number of ways you can do that. You can certainly do it by a vector search on the risk factors. But the challenge with that is if I do a vector search, one of the experiments we did with this data is we said, give me all of the risk factors faced by Apple. Now, the vector for Apple risk, remember, it's semantic, it's not structured. So it could go into those chunks, and oftentimes it would probably give you Apple. But what we noticed is when we increased the K, because usually in your retrievers, you're returning a certain number of chunks or a certain number of vectors. As we increase the K, one of the things we found is it started returning vectors from Microsoft documents because maybe Apple was mentioned or something similar to Apple or similar to iPhone or something that was semantically similar was coming in. And so what we know to be true is that sometimes the vector itself isn't going to give us what the structured element that we're looking for. Because in this case, I want to know what are the risk factors that Apple faces is my query, right? What are the top risk factors that Apple faces? You can see in my comments here, it's like detailed search with context or why this is a bad query. The reason this is a bad query is because this, as I said, as we increase the K, as we increase the number of elements we're returning, we end up not getting Apple at all. And so what we need to do is we need to refine how we're looking at it. Now, in our case, we happen to have extracted all those risk factors. When we ran it initially, we didn't. We tried running it, and then we said, oh, let's go in and extract the risk factors when we build the graph. So now if I want the risk factors from Apple, it becomes a straight match query. So match company where name is Apple and return all of the has risk. So it's really just this element here, company has risk factor, that then gets returned, and it's really straightforward and it's lovely. But there are times when we want to have a different element, a different type of traversal. So this is one of my favorite examples, especially in this data set, where we look at what is actually being returned and why do we need graph. You know, sometimes people will say to me, well, Alison, if you're just running vector search, I can use a vector store. And I'm like, yeah, if all you want is just the vectors, you can absolutely use a vector store. And then somebody else says, well, if I'm really just looking for something really structured, say those Apple has risk or asset manager owns, I can just use SQL for that. And I'm like, you're absolutely right. You can create a SQL tool, you can create a vector tool. But the question becomes, what happens when we need to traverse across the two, right? What happens when we get to that moment? So in this particular case, a prime example of this is this query here. Which asset managers are most affected by cryptocurrency policies? I can definitely look up cryptocurrency risk as a vector search, right? I could absolutely go into those chunks and do a vector search and bring back cryptocurrency, right? No problem. I can absolutely find out which companies are owned by particular asset managers, right? Like anything on this side, we could do a SQL query. Anything on this bit here, we could definitely do a vector. But the question was, which asset managers are most affected by a cryptocurrency issue? And in this case, the way that it works is we say, okay, I have a query that's based in unstructured data and is based in the vector, right? So what I want to do is I want to go through the vector search and give me all the chunks or the K chunks that are related to this topic, semantically similar. Then what I want to do is I want to find out which document it's from, which company published that document, and then which asset managers own that company. And this is where building out specific tools can be really helpful. Could you have something that's really dynamic where you say, okay, here's the schema, be super dynamic, create the query based on what someone's asking? Absolutely. You could do it completely dynamically. But if you know that this is a structure that's going to come up a lot or something that's going to be pretty impactful, if I'm building this agent to give me information about investing in asset managers based on what we've seen in these unstructured pieces, then this is a moment where I might want to create a tool. The way that we do that is with this retriever right here. And this is the piece. So if we look right here and chunk to asset manager query, one of the things you notice in the Cypher statement is it starts with node. And that means first it's running the vector search, and then it's finding those chunks. And then it says, okay, based on those chunks with node, now make this traversal. And in this case, we're saying go from the chunk to the document, to the company, to the asset manager. Return to me the name of the company, the asset manager name, so asset manager in shares. And you could also, if you wanted to also return, say, what is the value of what's owned, you could pull that property out as well if you wanted to do a certain kind of ranking. But the key here is how can we leverage these type of retrievers to build out a set of tools that's going to be helpful for our agent. The likelihood that you have an answer or a moment or a context that is a combination of some sort of structured data and unstructured data is, I've had a really hard time coming up with scenarios where that's not the case. I jokingly said to someone the other day, if you're working on these systems and you're not using Graph, you're probably building in some sort of technical debt. And this is why. There's a lot of talking. You'll see, other people from the company talking about these elements. We start talking about how do we manage memory? How do we manage context? There's a really great course that Andreas Kolliger, ABK from Neo4j, just released with Andrew Ng on deeplearning.ai. And it's all about the agent. We have some other folks that are working on some really interesting memory pieces, so you can definitely check out that content. But the reality is that in order for the agent to act effectively and to create the appropriate pathways and outcomes, the context or memory is key. The context is not flat. The context has some sort of relation in it. Some of my areas of interest really become about tracking the agent pathways, right? You see different types of observability tools. We look out for tool looping and things like that. The graph is really important. Clearly, we're showing how it's important as a tool and as a retriever, but it's really important as a structure around what you're building as well. So to get back to what we're talking about, structured and unstructured in GraphRAG, this really is the moment where I believe that the graph sings the most as a retriever and as a tool. We definitely have one other thing to note is we do have the vector cipher retriever example. And in this case, all that we do is we say we can actually pass different, well, this is the same piece here. Vector cipher retriever examples. This is another example of something where it was what might another tool be. In this particular tool, what we're looking for is we're looking for based on that node. So based on like in this query, I think we're looking at what are some shared risk factors. So if I wanted to know what are the risk factors shared by by companies who are impacted by a lithium shortage. So it would go to the lithium shortage or whatever my query might be. And then it would go to that company. And then it does another interesting traversal. It says, go to that company, find all the risks that it faces, and then show me all the other companies that face that same risk. Right. So this might be a tool where you're trying to look for, clusters of companies or maybe a cascading impact or understanding if one thing happens and this company is affected, what are some of those other pieces? So we've got an example of what that return looks like as far as the actual graphic. And in this case, is what we're seeing is we see these are the different companies. And this is where these are the risks that they co-share, right? It's always really interesting to consider what is the optimal answer and what information do we need for that agent to make a decision, for that final output after that agentic traversal. Really, in any given moment, if you have had a moment where you said, oh, I wish my agent knew X, or I wish I could pass this along. Imagine if you were able to pass not just the context in maybe a written context, but imagine what's possible if you were able to pass this graph of interconnections as context to your agent. Maybe it's this information and the previous few tools. There's any number of ways that you can evolve what's in this graphic form, and you pass it through as a JSON, right? You can pass this like very clearly through as a JSON, as we noticed when we were looking. Oh wait, no, it's not there. When we look at what those outputs are when we run the queries, you can have them come through in really consumable ways. But this is what I really want you to be thinking about. What is it that we can pass through that then becomes helpful? So in this particular workshop, what we do is we then go through. So we showed you a few of these different retrievers. This is a great retriever too, where we take the schema. So you actually get the schema from what you've built in the database. We pass that schema into Text-to-Cypher. And then from here, we can say, okay, what are the company names of companies owned by BlackRock? And then we'll actually create the Cypher query for you. So then you can go ahead and actually execute it. Sometimes folks will use this inside of building out a node or any number of different ways that you can create the Text-to-Cypher. But in the workshop, and what we show you is we show you a few different notebooks. The first one starts with a basic LangChain agent. And it creates this reasoning and acting agent, right? And the first thing that we do is, again, you connect it to your instance. But really what we're looking to do is we create this first tool, which is get the graph database schema, right? So in our case, we're saying the context is equal graph.schema. And the graph really is, in our case, you'll notice that we're using pieces that are already built into LangChain and LangGraph in this particular element. So we've got the create React agent, and what we're doing is we're saying, okay, get me the schema of the graph, and that becomes the first tool. And then you can say summarize the schema of the graph, and then it's going to give that back to you. Then what we do in notebook number 2 is we take that first tool that we built, but now we're going to expand it and add in a new tool. So in this case, we're saying, let's add in this retrieval query tool where we want to get the name of the company from that vector. I mean, it could be any of the retrievals that we shared earlier where there's a traversal of some kind. But really what we want to show is we want to show you how do you start to build out these tools in this LangChain, LangGraph scenario. So in this case, we've got it really straightforward. We've got this match element, match the node, and we're showing the traversal. This can get more complex, like we saw in those other retrievers. And now what we're going to do is we're going to say, okay, return this way, order by descending. And so this is what's going to be coming back from the retrieval query. We've got the vectors. So now what we're going to do is we're going to create a new tool called retrieve financial documents. And in this tool, what we're saying is we're going to chunk the vector. We're going to do the similarity search, right? The K is 3. And now we're adding this piece. So give me back those vectors. Give me back those chunks. So this is going to be pretty straightforward here. And we're returning the context. So now we've started out with getting the model. And now we can also add in these new tools to our tool list, right? So we had get schema, and now we can actually retrieve the documents from the chunk. And then in the final one, we're looking at the text-to-Cypher, which we talked a little bit about already. And the new tool that we're adding here is we're saying, okay, generate a Cypher template to query the graph database, only use the provided relationship types. We're giving it like some pretty clear direction, because one of the things that we know is that we've already built out how we pull in that schema, and now we're adding in the schema into whatever this Cypher template is. So now we've got the Cypher prompt, we're passing it the schema and the question, and then we're setting the template, and now we've actually created this new GraphCypher QA chain, and we're adding in these elements. A thing to note here, Martin, who I adore, who's one of my coworkers, put this piece in, and he's like, yes, just be aware you are trusting the generation of Cypher to an LLM. It may generate invalid Cypher queries, so please be mindful. As we have all learned from public discourse, you do not want to give your LLM generated queries free reign over your production code. So just a friendly reminder as always. But ultimately what we get to is we now have this agent built out where it has the get schema tool, the retrieve documents tool, and the querying of the database tool. So when you run this application, you'll be able to leverage all of these tools. The key to all of this for us is that what we want you to understand is as I mentioned, the likelihood that what is best for your agent is some sort of connection and relation is very, very high. Our goal and my goal in this talk today is to get you to see what's possible, how we produce and connect structured and unstructured data, and then how we then make that available as an example tool within the set itself. As I mentioned, this particular workshop and the details where you can reproduce it on your own is available at Graph Academy. A thing to know when you go to Graph Academy is that this particular workshop is not, it's publicly available if you have the URL, but you will not see it listed. So if you want to go through this, what I would say is if you have questions, feel free to reach out to me on LinkedIn. I am highly available and try to be as responsive within a day or two as I can be. But graphacademy.com/courses/workshop-GenAI. I don't know if somebody can drop that in the chat, but just know this is here and it's available to you. I am available, like I said, via LinkedIn. If you need anything, feel free to join the community.neo4j.com. We have a Discord channel that is also very active. And I really encourage you, take a look at Andreas's course with Andrew Ng at Deep Learning and dive into how you can improve your agents, not just with structured and unstructured data, but what is possible when we add this connected context to the variety of elements along your tool set. Again, thank you all so much. I really appreciate you. I appreciate your understanding of my lack of a face for you today, but please reach out with any questions you have anytime. Raja, thank you so much for having me, and I wish everybody good luck on the rest of your journeys throughout the course today and the talks today and your agentic moments moving forward.
Okay. Thank you so much, Alison. It was great having you. Do you want to, so we have some questions in the chat. Do you want to handle them?
Sure.
Or
Yeah, sure. Let me take a quick
Yeah.
peek. Okay, there's the
Yeah.
forum. Da, 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 da. Okay, we've
And
got your.
also, I mean, so someone pointed out maybe since it's a new laptop, sometimes they have those sliders on your camera.
You
Maybe
know, I tried the slider and
I
then it
see.
ended up looking like, where is it? Let me turn my video back on. When I tried the slider, and this is
Okay,
what happens when the slider is open. So for some
I see.
reason, I'm
Okay,
still not here. I don't know
something
why.
is off then.
Yeah.
Okay.
Oh, thank you so much for putting in the source to the workshop. I really appreciate that. Where are my Q&A? Oh, so many Q&As. Let's see. All
And
right.
I can help you filter them as well. I mean, maybe you can take a look and maybe I can also.
Okay, so I'm going to start at the bottom and move my way back up. So, how is the risk factor determined by domain knowledge expert, or is this automated? The way that it works with when you use the GraphRAG package is that when I set up that Python dictionary of the entities I'm looking for, that's the information I'm giving the LLM to go in and find those entities in the extraction. So, the risk factors are determined by the LLM which has gone into the documents to find what it deems risk factors and create those entities from there. Do you get a certificate for the Graph Academy courses? You do get completion certificates for Graph Academy. We also you can get certifications. We have 2 certifications. One as you have a Neo4j certification. Then there's also a Neo4j data science and analytics certification. So know about that. So if you don't have enough confidence in the LLM generated queries to run in a production environment, doesn't that nullify the whole point of LLM as a tool? I'm not saying that we don't have confidence, but just as a general caveat, we just always like to say, like, I don't want to be liable for, an LLM query, but honestly, most of the time they are very good. But it's more about don't have the LLM, delete tables, things that we know already. From YouTube, graph vector one use case is to make our search efficient. Yes. So the vector is very helpful in making it efficient. You are using cosine similarity to get as close to that semantic origin as possible. So it definitely will increase the efficiency in getting to that moment for sure. Yeah, let's see. Using GraphRAG, I use only Neo4j during retrieval, or do I need a vector data store? No, you do not need a vector data store. The vector is that embedding, and that vector is one of the properties on the chunk node. So you do not need a separate vector data store. And let's see, the same could be direct. Yep, we talked a little bit about how some of it is you could go traditional or live. Yes, there are real life implementations of MCP. I would say go to Neo4j, look up our MCP protocols. Michael Hunger, who's our head of innovation, our VP of innovation, has done some really incredible work with our team there. Study materials for agentic AI with examples there. I don't know if the Graph Academy agentic courses are out. I would say if you're looking for agents right now, I would go to that deep learning course. I would do that. That's the most recent release that we have is with deep learning AI. Yes, not all companies share the same risks. Some are common. There is a slight distinction. Does the full course for Neo4j Gen AI explain basics like what is RAG? Yes, Mustafa. Excellent question. I kind of gave you the fire hose version of what's in the workshop today.